Hey everyone, in this video we're going to make a vector field in Blender. This video is going to have a few main parts. We'll start by getting something up and running without any customization at all. Then we'll talk about how you can modify the vector field and its color scheme. Then we'll talk about how to generate these fields programmatically and how you can make them look good. We're going to start by going to this GitHub repository and downloading a few files. First, you're going to download generateVectorField.py, which will do all the work. Second, you'll want to download the arrow.obj file, which describes the 3D model for the vector. We'll talk a bit about how to make your own later, but for now we're just going to work with this one. To download the raw file, you click this button. You'll find both files in the download folder on your computer. I recommend you put them someplace meaningful. For me, I have them in the GitHub repository file on my computer. You'll have to keep the arrow.object file somewhere on your computer, but you can delete the script after you've imported it into Blender. Once you've downloaded those two files, you're going to want to either create a new scene or load an old scene. We'll create an empty scene for this video. Then you're going to want to go here, go to Open, find GenerateVectorField.py on your computer, and then hit Open Text. GenerateVectorField.py is now linked to your project. Then you're going to want to create a new Python file. We're going to call it SampleVectorField.py, but you should give it a good name in your project. Then you should copy and paste these lines of code. Import BPY allows you to interact with Blender through its Python API. The next line of code imports GenerateVectorField.py. You have to use this function to import GenerateVectorField.py because it's hidden somewhere in Blender instead of a standard Python path. You treat it like a standard Python module after calling that function. We call the module VecFieldGen. We'll use that name as a module to call the two functions that we need. We're then going to construct the vector field object by giving it the JSON file with the vector field data. We're going to go into the format of the JSON file later, but for now we're just going to focus on getting something set up, so you'll probably want to download SampleVectorField.json from the GitHub repository. You're going to want to put the path to the JSON file that you're using as the only argument to the constructor. Then you're going to want to call the generateVectorField function. Its two arguments are the path to the arrow.object file, or whatever file you're using, and the name of the collection you want to put all the arrows in. We're going to call our collection SampleVectorField, but you can call it whatever you want. When we run the script, we're going to get a collection called SampleVectorField with all of our vectors in our current scene. If we run this script, it won't work. This happens because SampleVectorField as a collection already exists somewhere in our Blender project, so the script adds all the vectors to that collection instead of the one in our scene. We fixed this problem by removing it along with a new collection the script made, and now we'll run the script. We now have all the vectors specified in the JSON file in our Blender project inside the SampleVectorField collection. That's it for the Blender part. Now let's talk about how to fill out the JSON file. We're going to look through SampleVectorField.json as our base. First, we have the minimum length. Vectors shorter than this length will be thrown away. Next, we have the max length. All vectors will have a length between 0 and the max length. This max length helps prevent vectors from getting too long and cluttering up the scene. The last length option is the average length. This is a bad name. But a vector with this length will be displayed as a vector whose length is half the maximum length provided by maxLane. Setting it low will make most vectors about max length long, and setting it high will lead to more variation in the lengths. Next up, we have the color scheme. The idea is that you give the script a number for each vector that the script will use to determine the vector's color along with the color scheme stuff. By default, this number is the length of the vector, but you can manually set it to whatever you want. If this number is between any two numbers in the color scheme, then the vector is colored with a mixture of the two colors. If the number is outside of the range, then it's going to be clamped to the closest color. Now let's talk about how we specify the colors in the color scheme. First, we have the color space specifier. For now, just put sRGB, which is the standard color scheme for most monitors. You can either specify the hex code if you set the format to hex, or you can specify the numbers as decimals from 0 to 1. The last thing you can specify is a dictionary of KWRs, just like in Python, to deal with the more general color schemes, like spectral colors. If you don't use a hex format, then the color variable will be a list of your arguments and they'll get dumped into the color creation just like normal Python arguments. Moving on, let's talk about how you specify the vectors. Position is where the vector will go. Vec is the vector. This vector will be at the origin and point in the positive y direction. This rot is short for rotation, and it will rotate your vector around the z-axis before rotating it to point in the right direction. We're not going to need it because our vectors are rotationally symmetric around the z-axis, so it won't do anything. Lastly, we have an optional color value that we can use to manually set the color for this specific vector. And that's it for the JSON file. As you can imagine, entering in all these vectors would be tedious and impractical.
Wait, SpongeBob! We're not cavemen! We have technology!
So let's talk about how we can generate these JSON files programmatically. I've written up a few of these scripts and put them in the demo folder in the GitHub repository. The simplest vector field in the demo file will generate a diverging vector field with uniformly spaced vectors. We start by using the Python JSON-mile, which we can use to convert native Python types into native JSON types. These next three imports aren't necessary, but they'll allow us to get a feel for how long the vectors are. We start by creating a dictionary that will be the outermost level in the JSON file. It has all the length variables and a color scheme, but the list of vectors is empty. These for loops will give us a bunch of evenly spaced points in a cube. At each point, we calculate the vector using a standard inverse square law. This will give you something like the electric field around a positive charge. I also have these two lines, and I'm going to uncomment them so you can see what they do. These lines will give us a graph that we can use to tell how long our vectors are. We could then use this information to better plan out the colors in our color scheme and the values that they should have. I would run these lines at least once to get a feel for your color scheme and your lengths. The result of this file is a script called divergingfield.json. It's been minified so it's difficult to read and it's not really intuitive what's going on, so we're just going to run the main script and see what we get. To use the new set of vectors, we delete this hierarchy to get rid of the old vectors. We then need to change the file name in our script to demo/divergingfield.json or whatever you name the file. To give the file a different name, you change divergingfield.json to something else. If we run it, we get a diverging vector field. I don't like this field though because of all the distracting gaps. So I created a second file. And then I created a third file that has the best of both worlds. You could find both in the demo, but we're going to focus on the one with both sets of vectors. The only difference is that we generate the points randomly but uniformly throughout the space. Let me know if you want a video on that algorithm as it's quite fast, but it's just generating points randomly and then putting vectors at each point. The result will be a file called random and stable diverging field.json. We go here, we delete the hierarchy, which takes a second, and after we delete it, we can rerun the script, which will also take a few seconds to load everything in. Our final result, again, has the best of both worlds. It has the randomly spaced vectors and the uniformly spaced vectors. There's no gaps and there's enough regularity that it's not missing anything. We're going to delete the hierarchy and move to the last example vector field. This one will use everything we've done up to this point with a more complex scenario and some manual coloring. We're going to plot the field around an electric dipole. We're going to set the color, not based on length, but electric potential. We can use negative values for negative potentials and positive values for the positive potentials. We can use the same exact algorithms before, but with a different vector field. We add up the electric field from every charge to find the field vector. Then we calculate the electric potential in the same way. This is the same way you calculate the field and potential as in Physics 1 or 2. We have to make sure to append the point as a list since JSON only supports native types and not numpy arrays. We then add a vector to the list of vectors with a position, the electric field vector, and we set the color using the potential. We generate points in the exact same way, so the color scheme and how we calculate vectors are the only changes. The output is toChargeField.json. We go back to the script and change the file name, and we have the electric field around two charges. From this angle, you can see that the arrows point away from the positive charge and towards the negative charge. Those are all the examples I want to talk about today, so let's move on to how you make these arrows. All the vectors are copies of an object file I exported from Blender. Making these vectors is basic Blender stuff. In this case, it's really basic. I put a cone on a cylinder. If you're still not convinced and think it's magic, you can check out this stream to see how I did it. Once you've made your object, you can export it. To do so, go to File, Export, and click Wavefront.object. Name it whatever you want. Before you save, make sure your up axis is positive Z. If your arrow isn't rotationally symmetric, then you also have to worry about your forward axis. Furthermore, don't export materials. Doing so is unnecessary since we're going to replace them once we run the script. Then you can just export it. I want to finish off by talking about the arrow material. The arrow material should generally look something like this. You should create an attribute with the name arrow color and pass it into whatever you want. Here I'm setting both the base and the emission color so it emits a bit of light, and that's the arrow material. Now Now that we're at the end of the video, let's go over some ways you could extend this script. For example, there's no reason we only have to set the color. Maybe we can make a data section for each vector that allows you to create and set arbitrary properties. The script would look the same, except you have a data section in the JSON file, you'd read in that along with the object, and you'd set the parameters in the same way you set the color. We could also extend it by allowing for animated vector fields, but I don't have a reason to do so right now. If someone wants to pay me though, that might be a good reason. Anyway, let me know if you want to see more tutorials or have any questions. Make sure to like, comment, and subscribe.